In this example, I want to graph the simple exponential function f of x equals e to the x and its inverse. So before I get started on these kinds of problems, I'd like to draw my axes and trace in the line y equals x, which is the line of mirror symmetry for a function and its inverse, and that's going to help us graph these functions. All right, to find the inverse, we'll write down the function and then just re-express it as y equals e to the x. And then, as we always do when we find inverses, we're going to swap x and y and solve for y. So to get y out of the exponent of the base e, I take the natural log. So the natural log of x is equal to y, and so there's my inverse function. F inverse of x is equal to the log of x. And so there are my inverse function and my function that I want to graph. Now, e to the x is a pretty simple exponential function. There's no translations that have been applied to it. So I know that f of 0 is equal to 1. So it goes through the point 0, 1. And it has this exponential behavior on the right. And then on the left side of the y-axis, it approaches the x-axis asymptotically. So the x-axis is a horizontal asymptote. Just so you can get an idea of what I'm talking about when I say sketch a graph, here are a few graphs of exponential functions with different bases. And you can see that they all go through the point 0, 1, and they all have roughly the same behavior. When we sketch a graph like this, we just want to have a curve that basically looks like this. The details we can work out later on a calculator or computer. All right, now let's graph this log function. If the exponential function goes through the point 0, 1, then the inverse of that function has to go through the point 1, 0. That's a property of this mirror symmetry of functions and their inverses. It has a vertical asymptote at x equals 0. So that's the y-axis. And then the rest of the function is just the mirror image of the exponential function. So knowing this mirror image property helps you to graph these much more easily. And so those are our two graphs, f of x and f inverse of x.